Hello! So today we're going to be looking at some UK Maths Challenge questions, in particular all to do with fractions. So in this first one we have a diagram here. All the small squares are the same size. What fraction of the larger square is shaded? Now this is really nice because there's loads and loads of ways you can do it. One way is to just count the amount of shaded grey squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 grey squares. So we have 9 grey out of, let's see how many total squares there are. So if I just change colour, we can see we have 1, 2, 3, 4 white ones, and then these two together make another one, 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 and then the four corners make another one. So if we have 9 green and 9 purple, that means altogether we have 18 total little squares, and so we have 9 out of 18 shaded, which is a half. So the answer is going to be a half. Another way to look at it that I think is nice is just by zooming in on a section, because actually this square here gets repeated throughout the whole shape, which means all we need to do is work out how much of this shape is shaded, and that would give you the same proportion of shaded for the whole big square. So you can see if I just cut these into pieces, we can see that actually in each of these little squares, half is shaded. Similarly, we have 1, 2, 3, 4 of these grey triangles, and 1, 2, 3, 4 of the white ones. So once again, it's half shaded. So whatever way you want to do this, the answer is a half. We could have even cut the whole shape into like these sorts of triangles. These little right angle triangles, and counted those. Either way, you'd get that half the shape is shaded. So there we go. Okay, this one. Now for each of these questions, make sure to be trying them yourself. So pause the video, give it a try. So when they're put in correct place on the number line, which fraction's in the middle? So we basically need to order these from biggest to smallest. Now, if we put 0 here, the tricky thing with this one, I think lots of mistakes can be made, is going to be when it comes to our negatives. In general, we know that the biggest number here is a quarter. Quarter is going to be my biggest number here. This is 1 out of 4 pieces. If I sketch it, for example, it's like I've shaded in just this much. A sixth, on the other hand, is cutting something into 6 pieces, which is pretty hard to do, actually. Maybe I could do it like this. 1, 2, 3. Oh, yeah, 6 pieces and shading in 1. So that's going to be smaller, a sixth. But they're both positive, both bigger than 0. Now, so let's just write that down. We have a quarter, we have a sixth. Now what else can we do? And this is where it gets a bit tricky. How do I know which of these is bigger or smaller? Usually what we do is we look at the denominator, and if the denominator is smaller, that means my fraction itself represents something bigger because I'm cutting it into less pieces. In this case, we can think about how far each of these things from 0. And actually the closest one to 0 is minus a seventh. It's only a seventh away from 0. It's only going a seventh away from 0. Minus a fifth, on the other hand, is going a fifth away. We're going a larger distance away from 0. So actually, on our biggest to smallest, the next one is going to be minus a seventh, then minus a fifth, and finally minus a third. I think a lot of mistakes can be made with these two, not knowing which one of these is bigger or smaller than the other. But really, because a seventh is smaller, when I subtract that, I'm taking away a small amount from 0, which means that minus a seventh ends up being bigger than minus a fifth. Minus a seventh is bigger than minus a fifth. Think about an extreme example. How about minus 1 over 700 and this? Like this. Here, in this case, this one, you might think, well, 700 is way bigger than 5, but minus 1 over 700 is so tiny, the gap from 0 to that is so much smaller than the gap from that to minus a fifth. So this would still be bigger than this. So when I put them in order, the middle one is a seventh, minus a seventh. So that fraction is in the middle. Minus a seventh is bigger than minus a fifth. We could also think about it, I don't know, you could convert it to decimals if you want, but generally just working out that minus a seventh is bigger than minus a fifth. Okay, for this one, once again, pause it, try it yourself. For these ones, we're just going to do our calculations. Although we might be able to see the answer straight away, let's just do each calculation. Here we need a common denominator, so we have 2/4 plus 1/4. So this one is going to be 3/4. This one we have a half minus 1/4, so that's 2/4 minus 1/4, which is 1/4. Okay, that's good. When we multiply, we just multiply our numerators and our denominators. So this is just going to be 1/8. 1/8. Now, when we divide, we have a half, and then we're multiplying the reciprocal of the second one. We're flipping the second number. This gives me 4/2, which is actually 2. We have a 2, we have an 1/8, we have a 1/4, we have 3/4, and finally, 1/4 times 2/1 will give me 2/4, which is a half. And actually, in this case, it's easiest to see which has the largest value. It is this one, which gives me the only integer, the only whole number, the only number bigger than 1, which is 2. So the answer is D. Okay, this diagram shows a square divided into strips of equal widths. 3 strips are black, 2 are grey. What fraction of the perimeter, so we're looking at the outside of this shape, is grey? So, try yourself. Lots of ways to do this. One way is to just think, okay, let's imagine that each of these is 1 centimetre long. This is 1 centimetre long. That would mean that this whole length is 5 because it's a square. This length also is 5, which is a square. And here we have 1, 1, 1, 1, and 1. Because they are equal widths, we could have said that they were each the same size. So we've just chosen them all to be 1 because it makes our life easier. Now we can just count how many are grey. We have 1, 2, 3, 4. There are 4 centimetres that are grey out of, what's the total perimeter? Well, it's 5, 10, 15, 20. 4 out of 20, which is the same as a fifth. We can divide the numerator and the denominator by 4. So the answer is a fifth. You could have also done it algebraically. You could have thought that each of these pieces are x, 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 and x. This length would be 5x, and we'd still end up with the grey bits being 4x out of 20x, which still simplifies to a fifth. So the answer is a fifth, because we're looking at the perimeter. The total outside is 20, not, I think as some people might think, 25, because they might have done 5 times 5, but that would give me the area. In fact, as an extension, see if you can work out what fraction of the area is grey. Write it in the comments below. Okay, this is one of my favourite ones. I'm going to make another video of this at some point because it's so easy to make a mistake. A fish weighs the total of 2 kilograms plus 1/3 of its own weight. What is the weight of the fish in kilograms? So what's your instinctive answer? I imagine for most people they've written this because they just do 2 kilograms plus 1/3. But it says 1/3 of its own weight. So we can actually think about this kind of visually. If this is the fish, although it doesn't look like a fish, it's 2 kilograms, plus 1/3, so this is going to be 1/3 of its whole weight, the whole weight. Now, if we have that being 1/3, what does that make the 2? The 2 would have to be 2/3 to add up to 3/3 altogether. So if 2 is 2/3 of the weight, 1 has to be 1/3 of the weight. So this is just 1. So the total weight of the fish is 3. The answer is 3. You can also think about this algebraically, although it's a bit trickier. A fish weighs 2 plus, and let's define W to be the weight, 2 plus 1/3 of its weight divided by 3. You could also write this as 2 plus 1/3 of its weight. And this equals to its weight. Its weight is 2 kilograms plus its weight divided by 3. So let's solve this equation. We subtract W over 3 from both sides. So that means 2 is the same as, well, 1W minus 1/3 W is 2/3 W. And that's actually exactly what we wrote down here, remember? And then to solve this, well, we can times both sides by 3. 6 is 2W, which means that W equals to 3. So I get that the weight equals to 3. What a great question that I think can give rise to lots of easy misconceptions. Finally, we have this. In this multiplication magic square, the product of the 3 numbers in each row, column, and diagonals is 1. Now, product means we are multiplying things together. Product is a multiplication. So we have, for example, that this, and this have to multiply together to make 1. So we have 1 times 1/8 times p equals to 1. So what would p have to be to make this true? We have an 8 times p equal 1, which means that p has to equal to 8. P has to be 8 to make this true. What can I do next? Well, I can look at column 2. We have that 1 times 4 times q equals to 1. So we have 4q equals to 1. 4 times what would give me 1? Well, that answer would be 1/4. So this has to be 1/4. Can you work out what r needs to be? Well, I've got 8 times 1/4 times r equals to 1. 8 lots of 1/4, well, that's going to be, I can write it like 8 over 1 times 1 over 4 if I want to, which is 2. So I've got that 2r equals to 1, so r has to equal to 1/2. So this is 1/2. 1/2. And I can just keep on going. Let's find u. We've got 1, we're looking at the longest diagonal, 1 times 1/2 times u equals 1, because all the products of each row, column, diagonal equals 1. So we have 1/2, we have 1/2 of u equals to 1, so u has to equal to 2. U equals to 2. We keep going. We actually only need to find r and s. We found r, let's find s. And we can do that by looking at this column here. We've got that 8 times 2 times s equals to 1. 16 s equals 1. S equals 1 over 16, a 16th. So we've got all our information. We know that r plus s is 1/2 plus a 16th. So let's get common denominators. That means we have 8 over 16, add 1 over 16, which is 9/16. So that's my final answer. The answer is 9/16. Now, there were probably other ways to work your way around this, but the important thing was realizing that product of multiplication, then using our facts, our multiplication facts, to get answers that are equal to 1. So there we go. Let me know in the comments if you've got different methods for answering each of the questions, and I'll see you in the next video. Make sure to subscribe if you want more content. Thank you very much.